To another live stream where I am coming to you from my classroom to cover my homework answers in graphing trigonometric functions. So what we're going to basically just discuss here is only looking at the characteristics of the sine, cosine, and tangent function. You can see these characteristics are listed up here: the period, the amplitude, phase shift, transformations, domain and range, and asymptotes where applicable. And then we're just going to do a rough sketch. I don't really teach detailed sketching of trigonometric functions anymore, so we're just going to kind of get things, just vary the basics, kind of get the max and mins as well as the initial period. Oops, sorry about that. So we have plenty of examples. I think I have 6 examples of sine, cosine, and tangent. And then what I'll do is I'll take a break. If you guys have some questions that you'd like me to answer, if you're going over any kind of questions in your homework, I'll be happy to answer those, as well as any questions you may have for anything that I am covering. And then we'll get right into the multiple choice questions. And hopefully I should have a little bit more extra time today in this stream. So, if you guys have any questions, please feel free to add them into the chat. I see Princess has joined in. Hello, Princess. Glad you could join on the stream. And what we'll do is, just kind of happy to answer any questions or help you along no matter what class you're taking. This is a homework assignment, again, for my pre-calculus class. That I kind of designed for them, and we're going to go over the answers to help them as well as to help you. So let's go ahead and get started. Again, I'm not going to take on too much comments, until I get to finishing off this first section. But I am going to kind of explain what we're doing here in each section, as well as how we identify everything. Now, and again, we've already covered this, so I'm not going to get very detailed in my explanations, but I do hope to at least cover things, so therefore, even if you haven't learned the graphing trigonometric functions, you can at least kind of follow along. So let's go ahead and choose green for this one. All right, so basically when we're looking into graphing these, or at least identifying these characteristics, we kind of want to remember the definitions. And so this is something that we covered in our notes. For this first example, I will express them all so you can remember where they come from, and then for the rest of them, we'll kind of work through them quicker. So the first one is identifying the period. And the period is basically just going to be, for sine and cosine, it's 2 pi divided by b. Now in this case, we can see that our b here is going to be 1. And just a quick little remember of our a, b, and c, a times cosine of b times x minus c plus d. All right? So we can say we have a b here. B in this case is 1, so therefore it is really just the 2 pi over 1, which is just 2 pi. So I don't really need to write that, but just figured I would. The next one is identifying the amplitude. And when looking into identifying the amplitude, that is going to be the absolute value of A, which in this case is going to be 2. So I'm just going to say absolute value of 2, which is just 2. The next one, here I'll zoom in a little bit closer, is going to be the phase shift. Now typically I don't really write in a phase shift if we don't have one. For this one I'm just going to write none, because you can see that C would be our phase shift. That's going to be shifting the graph left or right. And in this case we don't have a C, so we'll just write none. And then we have our vertical transformation, which is VT, and that's going to be for shifting the graph up or down, and that is your D, which you can see we're 1. So we're just going to say, up 1 unit. All right. The next thing we want to do is cover the domain and range, and I'm just going to kind of do this over here. So the domain is very easy for sine and cosine because it's all real numbers. Because these graphs, if you remember, we looked at them on Desmos, are just continue indefinitely to the right to left, oscillating up and down. For the range, this might be a little bit easier once we kind of get the rough sketch. But remember the amplitude, that's like your vertical stretch, right? We have a vertical stretch of 2. So the parent graph of cosine, let's kind of do a quick little sketch of the parent graph of cosine. Actually, I'll do it down here. So the parent graph of cosine, if you remember in class, has a period of 2 pi. All right, has a maximum value of 1 and a minimum value of -1. The minimum value occurs at pi, and then it has some intercepts at pi halves and at 3 pi halves. So the parent function looks like this, and I'll try to do my best here of graphing this. Okay, so that is the parent function. That is going to be y equals cosine of x. That is with no transformations, all right? So you can see here, this graph has a maximum value of 1, -1, right? So if we change the amplitude to 2, now the graph is going to go up 2 and down 2. Now, I didn't really give myself much space to go above this, but you can basically see now this graph is going to go, now the graph is basically going to go from up here and then go all the way down. Let's just say 2 is right here. Down to here, and then come back up and go back up to 2. So you could say there's 2, right? So you can see what's happening. All it's doing is being stretched. And then in addition to that, we also have a vertical shift up 1 unit. So not only is the graph going as high as 2 down to -2, now the graph is actually being shifted up 1 more. So therefore the minimum height, or the minimum value of my function, is now going to be at -1, and the maximum is going to be at 3. And those values are included. So let's go ahead and actually shift that graph up 1 so we can see what it would look like. And of course I lose my green graph. Perfect. Maybe I can put that back in. Nope. I should probably do a redo. Oh. Maybe it did work. Yeah, it did. Cool. So just put that back up. Okay. So now, let's go ahead and kind of sketch this as purple. So actually, you know what I'll do is I'll do this over here. So this graph is actually now going to look like this. Now this is not on the parent graph. So 1, 2, 3, 1, 2, 3. It's going to go up as high as 3, down to -1, and then up to 3. So we'll do this as 2 pi. So this is just going to be our parent graph. But the intercepts and everything is exactly the same. It does not shifting, up or down at all. And actually the intercepts are not the same. The intervals are the same, but it's not going to cross at the same x and y axis though, so I should be careful with that. But that is going to be, stop. Sorry. Okay, roughly. There we go. We'll stick with that. All right, so now let's go and take a look at the sine graph, which is going to have a different parent function. And we can obviously see we have some different transformations here. So let's go and do this one in blue. The first thing, again, we're going to look into our period. Now, again, it doesn't matter if it's sine or cosine. This is still going to have your same, transformations. A times sine of b times x minus c plus d. Not sure why I put that extra parenthesis there, so we'll get rid of that. And I think there's a little tab up there. Let me fix that. That's supposed to be a slow A. That's not a D. I don't want you to be confused. All right. So again, our period is going to be 2 pi divided by b. So in this case, you can see that our b is again 1, and our a is -1 in this case. So period is just going to be, again, 2 pi, because it's 2 pi over 1. The amplitude, I'm just going to write AMP. That's going to be the absolute value of -1, which is just going to be 1. And again, also that's going to tell us the reflection. Did I talk about reflections in this? I always like to leave reflections off. I did. Well, anyways, we have a negative on the outside. We're multiplying by negative outside the function. So that is going to be a reflection about the x-axis. So we're going to have a reflection about the x-axis. All right. And then let's go ahead and talk about phase shift here. So you can see that our c, you can see c is pi. So therefore, we're shifting the graph pi units to the right. So I'll say phase shift is pi to the right. All right. And then last but not least, we have our vertical transformation, which again is being added 1. So we can say up 1 unit. Let's see, where's that? Up 1. Okay, so let's go and graph what the parent graph of sine does. I'll use green, and I'll use blue again. So the parent graph of sine is very similar to cosine. All right, it's going to have a period of 2 pi. It has a maximum value of 1 and a minimum value of -1. All right, and it is going to, again, now this one is going to have an intercept at pi, but it has its maximum value occurs at pi halves, and the minimum value occurs at 3 pi halves. Okay, and again, this is just the initial period. Obviously, we talked about these graphs, continue indefinitely to the right as well as to the left. But this graph, at least the parent graph that we worked on our notes, is going to look like this, or close to something like this, because obviously my graphing skills are not going to be the best. Okay, so now let's go and take a look at our transformations that we have here. We have a reflection about the x-axis, so we're going to take this parent graph, reflect it about the x-axis, so this is going to go down there, that's going to come up there. We're going to shift the graph up 1 unit, so now instead of the range being from 1 to -1, now my range is going to be from 0 to 2. And then also the graph, instead of starting at 0, is now going to start at pi. So just to kind of do a rough sketch, and then we'll do the domain and range. So a rough sketch here, let's use purple again. Most of my rainbow, yeah. So let's just go ahead and I'm just going to go like my start and my end here. So basically, I'm going to now start at pi, and then if I add 2 pi to that, I would end at 3 pi. And again, I'm just doing the transformation from the initial period. Rather than going as low down as -1, I'm only going to go as low as 0, and I'm going to go up to 2. And again, I'm just doing a rough sketch here. So that's roughly what the sketch would look like. And then from here, I think it's easy for us to understand at least the domain and range. The domain obviously is always going to be the same. That's going to be all real numbers. And then the range, what we can see here, is going to be from 0 to 2. And again, that is included. Okay? Hey, Anthem, thank you so much for your super chat, man. I very much appreciate that. Don't really usually take a break here from there, but I do see that you have the super chat, so I had to give you a nice little shout out, man. I do appreciate it. I have a calculus test tomorrow. Best of luck, my friend. Best of luck. I hope you do awesome on it, and hopefully any of these videos for the trigonometry stuff that we've been covering is like a good review for calculus. I know that, obviously it's not everything we cover in calculus for my videos, but I do know that a lot of the students that, when I was teaching calculus, a lot of the things they were required for calculus, they forgot from pre-calculus. So hopefully a lot of these videos are helping you out, man. I appreciate the super chat again. All right, so now let's go and look at this. Now we can see that we have an A, which is going to be 2. So it's again the sine graph. So our period, we now have a B, which is 4. So my period is going to be 2 pi over over 4, which is my B. And that's going to equal pi halves. So now instead of the graph completing a cycle within 2 pi, now the graph is going to complete a cycle within pi halves. The amplitude is also now changing. Oh, crap. I forgot to do my reflection, didn't I? You guys forgot to keep me honest on this. Nobody mentioned anything. Yeah, so this is the graph there, but you got to do the reflection, right? You actually got to reflect this graph across the x-axis. So, I'm sorry, reflect the graph and then apply the transformation. So the graph actually is going to look like this. Here, it's actually going to go down first, then come up, and there you go. There you go. Kind of started talking. I'm not sure if the super chat got my distraction going, so just got to take it slow, go from here. The amplitude in this example is going to be the absolute value of 1/2. And again, remember, you can think of the amplitude as that's the compression, right? It's the half distance from the max to the min. Half distance from the max to the min of your graph. So now that's 1/2. So basically, without any transformations, my graph has now been compressed by a factor of 1/2. So that is going to equal 1/2. I do not have any phase shift. I'm not adding or subtracting anything, so there's no phase shift, and there is no phase shift or no vertical translation. So the domain and range is actually going to be pretty simple. Obviously, the domain is all real numbers. We like that. For the range, since there's no shifting, right? So look at the parent graph. Let's look at the parent graph of sine, not cosine. Here's the parent graph for sine. If here the amplitude is 1, it goes up to 1, goes down to 1. So if I have the amplitude now at 1/2, now the graph is only going to go as high as 1/2 and as low as 1/2. So therefore, the range is just going to be from negative 1/2 to positive 1/2. So now, and then also, I'm not having any shift, so it's still, the initial period is still going to start at 0, but now it's only going to go to pi halves. And if you wanted to see where the intercept would be, that would be at pi over 4. And you could use the X scale method to kind of get this, but I'm perfectly okay with just doing a rough sketch here, just to make sure you know the maximum, the minimum values, and kind of like where this graph is going to cross, which, there you go. And these would cross at pi over 8, which should be half of there. All right, so now let's do another cosine one. Now this one gets a little tricky because this is not in the format that I provided. The format that I provided here was a cosine b times x minus c. So you can see in this case we have a b as well as a c. So what we're going to want to do is we're going to want to factor out this 2. But the 2 is in the denominator. So there's some revisions here we can work on this. So the first thing I would do is I would rewrite this as the cosine of 1/2 x plus pi. Therefore, I can conceptually see I need to factor out a 1/2. And again, think of like factoring out a 1/2 as like dividing out a 1/2. Well, dividing out a 1/2 is the same thing as like multiplying by 2. So I can also rewrite this as 1/2 times x plus 2 pi. Now, if you're kind of confused as far as like, are you sure? How does that work? Well, again, just apply distributive property here. 1/2 times x is 1/2 x. 1/2 times 2 pi is pi. So you can see, now this is our case. Now we have a b as well as a c. All right? So our period and amplitude is just going to be like the, our period and amplitude is going to be the same, not our period, but our amplitude is going to be the same as our parent graph. But our period, we have a new b here, which is 1/2. So I'm going to take 2 pi divided by 1/2. And remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So that's now going to give us 4 pi. My amplitude is going to be the absolute value of a, which is 1 in this case. So we'll say that's going to be 1. Now my phase shift, and this is where a lot of students make their mistake, is, in this previous example, we used the phase shift as just, it was c, right? Because it's minus c, so it's c to the right. But that was because we didn't have a b, or at least b was 1. In this case, though, since my b is you can see we have a b, we have to make sure we factor it out. We don't want to say it's left pi, because when we factor that out, we see it's actually being left, we're actually going to left 2 pi. So my phase shift is going to be left 2 pi. And then I don't have a vertical transformation at all, so we're done there. So now let's go and take a look at just kind of doing a rough sketch here. So if I originally started at 0, but now the graph is being shifted to the left 2, my new kind of initial part, or new initial start of my initial period is going to be at negative 2 pi. And if the period is 4 pi, that's how long it takes the graph to repeat itself, well then half of that would be 0, and the other half would be at 2 pi. And then the amplitude is still 1 and negative, or 1, so I'm going to go up to 1, down to negative 1. And then I'm just going to sketch the cosine graph. So this will actually be at negative pi, and this will be at pi. You don't need to know the x scale, but it can be helpful to remember it. There we go, that's point. That point. There you go. So that basically covers the sine and cosine. Now what we're going to do is just 2 examples of tangent, and then if you guys have some further questions of anything else, I'd love to kind of catch into the chat and say hi to you guys before we get on to the multiple choice. So tangent is not completely different, but it is different than sine and cosine. It doesn't look anything like it. It's a discontinuous function. It's not continuous. It does still oscillate, or not oscillate, but it does still repeat just like sine and cosine. And it is a little bit shorter to repeat itself. The period is pi instead of 2 pi. And also there's no amplitude, because remember the definition of amplitude is half the distance from the max to the min. Well, what you'll see in the tangent function is there is no maximum or minimum, so we don't have an amplitude. But the first thing we're going to want to do in this case is find the period. And again, that is going to be, instead of 2 pi over b, it's just going to be pi over b. So in this case, it's pi over 3. All right. Now, we still have a 2 here. And what that 2 is going to do is that's just going to be a vertical stretch. So it is going to like make the graph skinnier than if it wasn't a 2 there. But it, again, it's not the amplitude. It's not affecting, there is no amplitude. And then also notice we have a negative here outside of the function. Did I really do one negative? I did one negative outside there. So we do have a negative outside the function, which is going to be a reflect of the x-axis. So we have the reflect the x-axis. All right. And that's it. That's as far as my transformations go. So let's go and take a look at what this graph looks like, the tangent graph. So this is y equals tangent of x. Did I label the cosine kind of function? I don't think I did. Let's write that in there. Y equals cosine x. All right. So the tangent function has intercepts at, or I'm sorry, not intercepts, asymptotes at negative pi halves and at pi halves. And what we did in my class is we looked at why those asymptotes occur by looking at the unit circle. And then we looked at the points and evaluated them to kind of make an understanding of that. And then the graph kind of looks like a nice little cubic kind of curves through there and goes just like that. Okay, and again, it's approaching these vertical asymptotes. And so you can see the distance from asymptote to asymptote is pi. And then what happens is these asymptotes just keep on repeating themselves, as well as the graph in the positive and the negative direction. So first thing is if I have a reflection here, this graph is now being reflected about the y-axis, so it's going to go in that format. And then now my period is going to be pi over 3. So I'm not shifting the graph left or right at all, but instead of it being from pi, now it's going to be to pi over 3. So what's really, what we can look at this then, is if you kind of notice that like without any transformations, half of the period is to the left, half of the period is to the right, right? So if my period, if I'm just trying to do a quick sketch, if my period is pi over 3, then half of pi over 3 would be pi over 6. And the other half would be positive pi over 6. Because you can see the distance from pi over 6 to negative pi over 6 to pi over 6 would be pi over 3, right? Pi over 6 plus pi over 6 is 2 pi over 6, which reduces to 3. And then remember our graph is going to be reflected and also very skinnier. So we'll just make it a nice little skinny graph. And that's probably not the best graph, but hopefully you can just see it's going to be skinnier because that transformation, it's going to be reflected. But it's still going to be approaching your vertical asymptotes from the left and the right. All right, now on this tangent, again, I did forget to mention, remember here in this case, guys, that the tangent function, still the a, b, and c are the same. We have a tangent of b times x minus c plus d. Okay? So you can see in this case, this is not in that format, right? So what I'm going to do is I'm going to want to rewrite this. We'll just do this a couple different ways. Let's rewrite this as y equals tangent. Let's put the x in front, negative x plus pi minus 1. And then we notice we got to factor out that b. So yeah, y equals tangent of a factor out a negative, and you're going to be left with x minus pi, and then still minus 1. Okay? So when identifying here, my period has not changed because you can see the 1 in this case, or my period is still going to be, or you can see a negative 1 there, but my period is still just going to be pi. And there's not period is a distance, so it's like the hypotenuse, it's not going to be negative. So the period is not positive or negative, it's just going to be pi. I do have a phase shift in this case. You can see that when I factor out the negative, I am going to go to pi to the right. Oh, I forgot to talk about domain and range, didn't I? Crap. I'll come back to those domain and range. Don't let me forget the domain and range. And then, let's see, we also have a reflection about the y-axis because we're multiplying by a negative inside. So we reflect the y-axis, and then we're actually going down one as well. All right, so a lot is going on right now. So our period is pi, and we're also moving pi to the right, and then we're reflecting the y-axis and going down one. So let's look at this parent graph, right? All right, so the parent graph has an x-intercept at 0. So if I shift this graph pi units to the right, the new x-intercept is going to be at pi. So let's go ahead and graph that. So here's my new x-intercept, which is at pi. All right. Then the period is pi. So that means half of the period to the left is the asymptote, and half of the period to the right is the other asymptote. So this might be a little confusing as far as our fractions, but so if I do pi minus half of pi, which would be pi halves. Right? So it's really plus or minus pi halves, actually, I guess I could write. So let's rewrite this as 2 pi plus or minus pi halves. 2 pi over 2, sorry. Over pi halves. So therefore, this asymptote is at 3 pi halves, and this asymptote is going to be at 1 half, or just pi halves. So let's go ahead and get that going in there, and this one. And you could actually see this is actually going to be, that would be actually this graph right there. It's really the same. It's actually just a repetition there. And then we have the graph is being shifted up one, and it's reflected about the y-axis. Well, if I take this graph and reflect it about the y-axis, it's kind of like the same thing as reflecting about the x-axis. And the reason why that works is because tangent is an odd function. But either way, we don't have a stretch like the last one, so I'm going to kind of curve that one out a little bit more. And voila, we have our nice little graph, which is going to cross here at 1. Now, I forgot to mention the asymptotes for the other tangent function, so let's kind of talk about that. Let's get the range out of the way, because range is very easy. The graph, you can see, continues to negative infinity and continues to infinity. So the range, we love the range for a tangent. That's negative infinity to infinity. All right, but the domain is a different story. And obviously, the domain is going to be all real numbers except for where the asymptotes occur. So, we got to kind of understand where are these asymptotes occurring. Now, here I graphed it, right? And from here, you can easily identify the domain based on the graph. But I don't want you to just rely on what the graph is, because some people, graphing is not required in my class. So let's kind of talk about what are the asymptotes of the parent function. So the asymptotes of the parent function, you can see that this, let's just pick one asymptote. Doesn't matter. Let's just pick x equals pi halves. Now, the distance from each asymptote is going to be pi. So that means if I add pi to this pi halves, I'm going to get my next asymptote, which would be at 3 pi halves. But what if I subtracted pi? I would also get to the next asymptote. And then I could keep on subtracting pi or keep on adding pi. So what we use to represent that is n, where n can be any integer, -1, -2, -3, -4, 1, 2, 3, 4. And what this is representing is that asymptotes are going to continually repeating. I don't know why we did AYM. Okay, so we can write this expression. Now, so what do we do when we've had these transformations, all right? Well, basically what we can do in this case is the 1 is not going to affect the asymptotes, but this negative pi minus x, set that equal to one of your original asymptotes, which we can just say is pi halves. Okay? And then what we're going to do is actually solve for x, because basically if my original asymptote occurred at pi halves, with these transformations, I want to see where the new asymptote, where that new asymptote will be. And that's basically kind of comes into my phase shift, which is pi right. So when I subtract pi, I'm going to have a negative x equals pi halves, and then I'm going to change this to a negative 2 pi over 2. And that gives me negative x is equal to a negative pi halves, divide by negative 1 on both sides. And I can say x is going to equal a positive pi halves. All right, so Yeah, so my new asymptote, you can see that was the asymptote for one of the asymptotes I found, right? So, and then what we need to do is now just simply add the period. So what I did is I took my original period, and I took my original period and I took my original asymptote and I added the period n. And that's exactly what I'm going to do here. I'm going to take pi halves and I'm just going to add, my new period is pi. All right, so I'm just going to add pi n. And if n was 1, you could see that would take you to that asymptote. If n was 0, it would take you over to that asymptote. And then negative pi minus x. Yeah, okay. So that way, that is a way for us to identify all the asymptotes. And then as far as the domain, there's a couple different ways, we can write this. One of the easiest ways, just, I think is set notation, all real numbers such that x cannot equal pi halves plus pi n. All right, so let's go and take a look at this one using the same idea. Here we basically have 3x if I wanted to find the asymptote. Let me actually label that. That is the asymptote. All right, so let's go and do the asymptote again. So if I was going to find the asymptote over here, I would take 3x is equal to pi halves, divide by 3, and I get x is equal to pi over 6, right? And now you can see that's my asymptote. And then to get to my next asymptote, I'm just going to add my period, which in this case is pi over 3. So I just say plus pi over 3n. And therefore my domain would just be all real numbers such that x cannot equal pi over 6 plus pi over 3n. And then before I take a break, did I do the domain over here? I didn't. Why didn't I do the domain here? Well, let's go and look at the graph here real quick. The domain, that's all real numbers, that's easy. And the range, that didn't change at all, so that one's easy too, and that's negative 1 to 1. All right, so let's go and take a break. I'm going to work on some multiple choice questions here. After that, you guys can go ahead and feel free to work on those as I go ahead and check in on the chat. So, hey AJ, hey Francis, Kingpin, Cooler, Harshit, Charlie, D, Mr. Dr. Prell, Ahmed, the math guy. Good to see you guys. Happy you guys could join in the stream. Sorry for taking a little bit longer than I getting in there, but obviously if any of you guys have been on my streams before, you notice that I just focus in on getting that free response because I try to limit the questions for my students to not to take that much time. But usually my streams have been pretty consistent around like the 40-minute mark. And that usually comes in with a little chit chat of myself kind of talking about some random things or helping out some questions. So anyways, it looks like we're kind of, on par. And again, just a reminder that I cover the graphs, but that's not something like a main important that I really ask, a lot, for my students from there. And I used to teach this like step by step, like my test on graphing trig used to be like every single point you had to be accounted for. And nowadays with technology, I just don't think that's really useful. But from teaching calculus, I know the basic understanding of what these transformations are doing of the graph, how this graph looks, I think is very, very helpful as far as like your understanding for that. So, that's why I did want to kind of cover the graphing section for you guys. So AJ says, what is 2 plus 2? I'll go with a guess of 4. I can't pronounce the name. Seems like Russian lower. Side question, how do we complete the square if we have x, y? And you know what? I'm not really familiar with doing a question like that, so I'm not sure. I haven't really played around with it. And I'm not sure if you would be able to or how you'd be able to or what algebraic you would have to be able to do. I'm not sure if I've ever had to cover a problem like that. So immediately off my mind, I'm not seeing a best practice for you to approach that. It'd probably be something that I'd be spending some time looking at and trying to like refresh my good old math skills. But I don't want to spend that much time on the live stream just trying to go back and figure things out from there because it definitely would have been a while since I've been covering anything like that. So sorry for going there, but if there's any other questions you guys have about math, then I'll be happy to kind of answer. If you have any questions in your own class, then we can discuss any of that kind of stuff too. So I also, to kind of let you guys know, I am also pushing these onto my Facebook page, which I kind of decided I really wanted to kind of continue adding some resources on my Facebook page, free math videos for those of you that are on YouTube, but also prefer to, be on or also on Facebook as well. So feel free to kind of join on there. A little bit different things. It's a little bit more easy to, interact with people, answer some questions, and then obviously for live streams, for people to basically kind of post some questions that you guys have. So I do kind of like that feature of Facebook in compared to YouTube. But I'm not going away from YouTube. I'm still going to be doing all of my main videos as well as my main live streams are going to be back on YouTube. So don't worry about that. And then just also a reminder for any of you guys that are interested in the documents that I have. I have a link down in the description below as far as my Patreon or my channel memberships that will basically get you access to the quizzes, the tests, the homework, and the written out answer form. So you don't have to listen to me talk, or just a blank copy, so you can go ahead and try it for yourself and kind of see how you are. It's not a complete list yet, but everything as we're working through this pre-calculus curriculum, I am providing in those platforms. So just for those of you that are maybe taking this class that you feel is beneficial, that is one thing I have for you guys. So, all right, I am going to get started here with the multiple choice, but if you guys do have some questions in the meantime, feel free, and hopefully I'll maybe have a couple minutes at the end. I'll help you out. And hey, Kitty Gamer, how are you doing? So let's get on to this. Multiple choice, we like multiple choice. They're not going to take as long as those free response. So this one says state the amplitude and the period of the function. So the amplitude is obviously absolute value of -3, which is 3. So I know it's not D, and I know it's not A. The period is going to be 2 pi over 3. So I can see that 2 pi over 3. I can see my answer is going to be C. This one, I guess I forgot to write in the directions, but the directions are going to be identify the transformations, or it looks like identify the phase shift. So basically what I can do here is factoring out a 4 can be kind of difficult. So again, if you think about like the initial period of sine, again, starts at 0. And if I want to see with these new transformation, where is the new start, all I got to do is set 4x minus pi halves equal to 0. That is my new start, right? So the original initial period starts at 0. The new start is going to be whatever x equals. So I can just go ahead and solve for x here. And when I divide by 4, I get x is equal to pi over 8. And that's a positive. So instead of starting at 0, I'm starting at pi over 8. So I can see it's pi over 8 units to the right. That is my answer. You could also just factor out the 4, which I prefer. So if you just rewrite this in the form of b times x minus c, by factoring out the 4, again, factoring out is like dividing out. So you're like dividing a 4 by 4x as well as a 4 by pi halves, and you would get a x minus pi over 8. And again, that is going to tell you pi over 8 units to the right. So the answer is C. And next one, the minimum value. So I had a student come in for class today. This is an example of something that we didn't really talk about in class, but it kind of goes into the concept of what we're covering. So if we look at the cosine graph, just the parent graph, we can see that there is a minimum value of -1, right? And if I change this function to, so this is y equals, let's say that's y equals cosine of x. Now, if I change this to y equals 2 cosine of x, that's 1, you can see that now the graph is going to go up to 1, I'm sorry, down up to 2, and then down to 2. So the amplitude, remember the number in front, that tells you how high and how low the graph is going to go. But in addition to that, we also have y equals, let's just do like cosine of x plus 1. If I add a 1 on the outside of the function, basically what that does is that takes the function and just shifts it up 1. So that graph would look something like this graph, but right there. So what you can see is there's two things that's going on. We have this 37 and the 21. So the 37 is basically saying, now again, don't worry about the negative because that's just a reflection. If you just reflect, that's not going to affect it. But you can see the 37, what that's telling us is this graph goes as high as 37 and as low as 37. The x minus 3, that's left or right, so it doesn't affect. So we're trying to find the minimum value. So we know this graph goes down 37. So the minimum value right now is at negative 37. But then it's being horizontally shifted 21 units up. So therefore, we know it's going to be a negative value. And obviously, it's not going to be down, but it's going to be a negative 16. Because you go negative 37 and then up 21, which would give you a negative 16. And then last question, number 4. I mean, about as easy as we can get as long as you know what the period of tangent is, which is pi over b. You can see my b is 2. So that's pi over 2. Answer is b. So there you go. Nelson says this guy has all the math concepts pre-downloaded. No, I will make mistakes all the time. All the time I make mistakes. And, part of that reason is, just kind of being careful. When I'm teaching, a lot of times, like, I'll be thinking about what I'm going to say, and then I'll just start doing something that is completely random and doesn't make any sense, So I do got to watch myself as a teacher because even though I'll be doing math, you'll be thinking about something or saying something, and you got to get off track. Like, for instance, I totally forgot to do the domain and range on a whole bunch of these. So I had to go back, and do them. But, just kind of review the major concepts, for you guys is really making sure that you understand the parent graphs for tangent and sine and cosine. And even though you might not graph, or at least I, require my students to graph, I think just understanding what these characteristics do, as far as the stretching, compressing, shifting left or right, is going to help you understand like what the new graph would look like, even if you don't have to graph it. And then in addition, the period, the amplitude, domain and range, these are all things, vocabulary that is going to keep on coming up, especially in the class, which will be helpful. So, but either way, that's, I guess my voice is getting a little raspy. I don't feel totally sick, but I can see I've been talking. Obviously, I got to make quite a bit more videos for the class, but if you guys don't have any more questions, I guess we'll end it up. And now the day is over for me to go and pick up the kids. So I will let you guys know though. Actually, I am going. Today is what, Tuesday? So either tomorrow or Thursday. I can't schedule this stuff. I'm sorry. But Wednesday or Thursday, I will go live. My next live homework questions will be covering graphing reciprocal trig functions. So we're going to cover reciprocal trig functions next class period. I'll either do a live stream tomorrow or we'll do it on Thursday. Just kind of see how my schedule shapes out for you guys. So again, hopefully to see you guys then. And obviously, if you want to be notified, you can just hit the notification bell. Otherwise, you can just play roulette and know that I'll be going live one of those 2 days around the 3 or 4 o'clock time frame. So until then, guys, cheers and happy to help you out, and I look forward to seeing you guys on the next stream.